That word right there is just another way of saying electronegativity. All right, now, those of you who are basing it based on ionization energy aren't going to get the wrong answer because you know ionization energy and electronegativity are the same trend. All right, so who would have the greatest electronegativity on the periodic table? Anybody remember which element has the greatest electronegativity? F. Okay, so as you go closer to F, the element that's closer to F would be which one up here? Chlorine. That's why chlorine is the answer. Okay. As long as you do it on the exam, okay. Who has the largest atomic radius? Yeah. The trend for radius as you go across does what? Decreases. As you go down, it does what? Increases. Everybody okay with BA? Yep. All right. Which of the following has a covalent bond? Okay. How'd you know it was the first one?
Numbers on that one chart.
Okay, so you're going to have that on the exam. Probably not. So how are you going to know if you don't have that on the exam?
Yeah, both on the ones on the left.
Okay, so you're going to look at the periodic table, and if you have a metal and a non-metal, it's what kind of bond? It's ionic. If you have two non-metals, it's what? It's covalent. So who up there is two non-metals? The first.
But what would we, like, how would we even use that scale?
They'd have to give you the numbers in the question. They'd have to give you a small chart and say, these are the electronegativities for the elements. If they don't give you that, then you won't be able to use the scale. But they'll include that in the question. All right, which one would have a bent geometry? Okay, which ones would you automatically eliminate based on formulas? The last two. Okay, you would know that PCl3. Okay, just looking at this, what would you know about this? It has to be either triangular planar or triangular pyramidal. Okay, you can't do any better than that, but you know that. This has to be what? Has to be who?
No.
What did you say, Devontae? It's got to be tetra. It's got 4. 5 is who? Triangular bipyramidal. I will tell you the 5 and the 6 will not be on the exam. Okay? The ones that had 5 and 6 will not be on the exam. 6 is octet. It won't be on the exam. The 2 expanded octets will not be on the exam. Okay? So you've at least eliminated those 2 from your choices. Now, from there, you're down to these 2. You got to know, based on lone pairs, who's bent. So the only way you can figure that out is to do what? You got to draw them. You got no other options but to draw these 2. So, SEI2. How many electrons in SE's outer shell? 1, 2, 3, 4, 5. It's in group 16, so it has how many? 6. I is in group 17, so it has 7. Has 1 atom. This one had 2, 6, 14, 20. Who's the central atom? Se. There are 2 I's, so I draw 2 I's. And I need 20 electrons, right? So 20 electrons. 2, 4. I'm not starting with any double bonds. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, it has 2 electrons on Se. If I draw CO, C has how many electrons in the outer shell? It's in group 14. O is in group 16. It has how many? Times 1 times 2. I get 4. I get 12 for a grand total of 16. C's in the middle. How many O's? 2. All right. 2, 4, 6, 8, 10, 12, 14, 16. Does everybody have 8? So what am I going to do? All right. What do you look for to be bent? So who's bent? The one with the eyes. So SEI 2 is bent. Questions? See how we eliminated based on the formula? So you didn't have to draw everybody? Okay.
Wait, can you go back to the geometry for the?
There?
Yeah.
Okay. Now, the plan for this week is for me to hit some topics Monday, Tuesday, and Wednesday. We'll save Thursday and Friday for review. That's not a lot of time for review. Okay? I'll do more Tuesday and Wednesday after school in what's sort of a modified blitz. Okay?
What's the actual day of our exam?
Your actual day of your exam is next Monday, a week from today. Y'all are first period. This time next week, you'll be sitting here with somebody else with computers in front of you. You'll have assigned seats. I will predetermine whose seats you have. Okay? Who sits where. I will not be giving your exam. All the tables will be covered. All the desks will be pointed frontwards. Okay? The exams will be like they always are in every other class you've tested in. They'll be predetermined and pulled up. You'll have a sticky note on your desk. I know some people don't use sticky notes. The calculators, I don't set the calculators out. I let the person who's giving the test hand them out because the directions ask that the person hand the calculators out. So I don't set them on the desk. Okay? You will have to turn in your cell phones. So please don't make that an issue. Make sure you turn them off when they ask you to turn them off. If they don't hand them back to you when the exam is over, I will hand them back to you when I get back. Okay? Ms. Henson has always said we can, so I will hand them back unless she tells me something different today. The Wi-Fi will be cut off. You'll have to use your own phone internet service data so that you can use your phone. So as long as you're cool with that, you can watch whatever you want on your phone when I get back.
So I have a question about
Yes.
the board absence deal.
Yeah.
I know you said that like today you're going to be counted out regardless, but another teacher told me that the cutoff date this Friday.
The cutoff date in terms of counting you absent is this
I
Friday.
know it's going to show up in Power School, but
Right.
since I only have two and multiple classes of one, like I can't fail from this next week, right?
No.
Okay, well, because I want.
Even if you're on 8 this Friday, it does. When we mark you absent next week, it still won't fail you.
Because I wanted someone to confirm that, because everyone, they say like this, and they're like, wait, and I'm like, tell me yes or no.
They're not supposed to tell you.
We cannot tell you not to come to school next week.
Okay.
Okay?
I mean, obviously, no one's gonna be here to have exams.
Exactly.
That's the thing. Okay, so I just want to make sure.
Yes.
Yes.
We're not going to tell you not to come to school. However, for attendance purposes and counting towards your 8, we stop counting this Friday. But for the purposes of attendance for lunch, for fire, for whatever, we have to mark it in Power School beyond Friday. Okay, but people who are on 8 this Friday, we only count through this Friday. Okay, so even though they might get to 12 by next Thursday, we don't count those other 4. Okay? You with me on that? Are you with me on that?
Yeah, I get it.
Okay. I don't know how to say that any plainer. All right, find your notes. Thank you, Marcia. All right, so on Friday, we started talking about shifting with LeChatlier. Now, we talked about the 2 rules. and we tried to do an exam. Okay? So let's see if we can go back and make sure everybody understands it. Now, at the end of today, if you've got it, great. If you don't have it, I'm sincerely sorry. Okay? This isn't one of those topics where I'm going to spend 2 days trying to make sure everybody's on board. Okay? At the end of today, we move on to another topic. So, we have 3 days. I'm going to try to hit 3 different topics. Normally, we'd have 9 days, and we would be in better shape. But we're going to take 9 days and squish what we can into 3 days. Now.
So that's like 3
Yeah, it's not a lot.
per day.
Yeah. So, on Friday, we said that if we have a reaction, such as this one, all right, and I increase my pressure, all right, we want to figure out which direction will the reaction shift. Now, once we know which direction the reaction will shift, we want to know what happens to the concentration of CO and what happens to the concentration of CO2. Remember, the brackets mean concentration and shorthand, so I don't have to write out the words. So, according to the rule, if we increase pressure, what did we say would happen?
Go to the more side.
Fewer side.
Okay. I go back. If I increase pressure, I go to the side of what? Fewer moles. Okay? So, I go to the side that has fewer moles. So, looking at our reaction, how many moles are on the left side of the reaction? And all of this is analysis. These are upper level thinking skills. You got to stop and calculate and think through the problem. So how many moles are on the left? There are 3 moles on the left. How many moles are on the right? All right, so if we increase pressure, which side has fewer moles? To the right. So this reaction is going to shift to the right. Okay? Are you with me on that? Now, from there.
3 moles.
So you don't count.
It's 2 plus the 1.
The 2 didn't count.
Say what?
The 2 didn't count.
What doesn't count? 2 plus 1 is how we got 3. Are you with me on how we got 3? We counted the coefficients. So 2 plus 1. So 2 plus 1 made 3. That one only has a 2. That's why we said it was 2. So if I did this one, for example, how many moles would I have on this side of that reaction?
4.
There'd be 4 moles on this side. And how many moles on this side? 2 moles on this side. Does that make sense? Okay.
Wait. Okay. You're gonna go back to that problem?
I can in a minute.
That's just like an example.
Because I'm wondering what like the parentheses blank body.
I can go back to that in a second. All right, so to figure out concentration, anytime the reaction shifts to the right, what's going to happen to the concentration on the right side? Is it going to increase or is it going to decrease?
Increase.
Okay, the concentration of the products will increase. So what's going to happen on this side? Okay, the concentration of the reactants will decrease. Now, this never changes. Now, don't want to be quiet. It doesn't matter if we're talking about pressure, which is what we're doing right now, temperature, or concentration, which we'll do in a minute. This never changes. If we say shifts left, okay, because in a few minutes with something, you will tell me it shifts to the left. If it shifts left, what's going to happen to the concentration of the reactants when it shifts to the left? Okay, will it increase or will it decrease? It will increase. What will happen to the concentration of the products when it shifts left? It will decrease. Okay? Anytime it shifts to the right, if it goes right, whatever's on the right increases. If it shifts left, whatever's on the left will increase. So if we go back, pay attention now, Maja. Don't zone out on me. You're going to get lost quick with this. So if we go back to what y'all told me, you said it shifted which direction? To the right. So if I ask about CO, whatever's on the right is going to do what? Whatever's on the left is going to do what? Because you said it shifted to the right. So what's going to happen to my CO? It's going to decrease. What's going to happen to my CO2? It's going to increase. Are you with me? I know Devontae is. I ain't sure about the rest of you.
Okay, wait.
What was the very first
Okay,
slide? It was that thing.
The lower, the higher. We did that Friday, and then it was. You had
Oh,
like
okay.
shifts right, blank volume.
That's just,
Yeah. Okay.
that's another way to increase pressure. If you increase pressure, what can you do to volume to increase the pressure?
That's already
I said that.
I know it's already in your notes.
I didn't get it.
Think Boyle's law, back when we did the gas laws. How else can we increase the pressure besides increasing the pressure? What can you do to the volume? Shrink it. So what is the word I can use besides saying shrink it? That's right. We can decrease the pressure. All right. And another way to decrease the pressure besides saying, what can I do to volume? You can increase the volume. Means the same thing. Okay. It's just another way to change pressure without actually saying pressure. It's Boyle's law. Yep. There. What's the relationship? Decrease, increase. Inversely. Okay, so let's say that I increase pressure here. What happens to the concentration of ammonia? Will it increase or decrease? Okay, what's the first thing you have to figure out? Does it shift left or right? All right. So if I increase pressure, does it go to the side of fewer moles or more moles according to the rule? We cruise back. Oops, not quite far enough. If I increase pressure, it goes to the side of what? Fewer moles. So which side is the fewer moles on? Fewer moles is where? To the right.
Can you just think of it as like the whatever is moving always moves to the direction that the reaction shifts or
Sure. All right. So ammonia is where? Here, right? So this side's going to increase. This side's going to decrease because you said it was going to the right. So ammonia is going to do what? Increase. Now, what if I give you this?
Huh?
Oh,
Tell me what you know about the reaction before I even ask a question.
it's the same number.
what's the same?
What's its name? Just give me some science word. Same number of moles. So would pressure affected? No. Pressure will have no effect.
So that's the answer would be no effect.
Correct.
So if pressure has no effect.
That is correct. That's right. Pressure will have no effect because the moles are the same. Don't need any of that. Don't write it. Okay? All right. Changing temperature. One of these I forgot to bold. It's in the next rule. All right, let's change temperature. Told you I was doing concentration last. From my previous semesters, people keep telling me that one's harder, and I don't understand why. I think it's the easy one. All right, so if we remove heat, all right, it will go in the direction to make or produce heat. So it goes to the warmer side.
So for the first one, can we just say we'll go in the direction that produces heat?
I'm going to show you how to do that. I'm going to make it easier for you in a minute.
Is that a grammatical thing that in the first one?
Where you at?
The very first sentence.
We'll go in the direction to make, yeah, or produce heat.
Oh.
Yeah, sorry. There. Is that better?
Yeah.
So, question. What is, okay, I have another way of putting it. How are we looking on doing well on his end?
At this point, I think it's a crapshoot.
What the heck? That makes me feel amazing.
Like, regardless if we study or not.
No, I think I'm always pleasantly surprised when I get my scores back. But I'll be honest, I'm worried. We lost 6 days. If we hadn't lost 6 days, I would feel very confident that y'all would do well.
Well, my mom seems to be very confident.
I'm always very confident that my students will do well. I do a very good job of preparing my students for the exam. I can say that very honestly. All right.
But you're not confident with us.
I'm not at the moment because we lost 6 days. I've never lost 6 days before and had to have my students take the exam. I've never been this far behind and been asked to have my students take the exam. So this is a first for me. Well, I take that back. We were probably this far behind the year my mother had a heart attack and I missed 2 weeks of school right before the exam.
That's a little different.
And that's true. And even that, there was a dip, but it wasn't bad, so maybe it'll be okay. It wasn't, and even that wasn't that bad, so I think we'll be okay.
Would you say there's a curve on it?
There is a curve. It's not as dramatic as some classes.
I mean, if I pass, I'm going to do nothing.
Yeah, they be
try to
good.
pass this.
They're making you feel good.
It's not the
Huh?
No, that's what makes sense.
It'll just shift. And today asked if it snows this weekend, we don't go to school Monday. The next day we're here will be your exam. They won't
They're
push
calling
it.
for snow.
There's a chance.
It's 30%.
It's not high. It's only like a 1 to 2 inch chance of snow.
I'd be okay if it went.
It's not a high chance at that. Okay,
It
and
can wait
this
till
is
after
gonna get
exams. I
high.
want to get them over here.
I do too.
But
And we don't need anything else messing with it.
I don't know. I liked when we had cold weather. Like, there was cold weather and we had to come on the winds.
I mean, if they're gonna mess with the schedule at this point, it would be nice to get exams over with. All right, now, I don't think you really need to write a lot of this. We're just gonna hit the highlights because at this point you should know all of this. So let's just talk about it. Don't write it unless it's something that you're like, dang, I don't remember any of this. Okay? I'm just moving the arrows. Now, don't write the orange at all. Okay? Now, everybody should remember that enthalpy means heat content, right? I'm not just shaking your head no at me. All right? You might need to write that one down. Enthalpy means heat content, and its symbol is delta H. Okay? Now, they can give you this information in one of two ways, okay? Now, they can either flat out say delta H is a positive number, okay? So if delta H is a positive number, it tells you it's what? Endothermic. Do you remember that? If you don't, write it down. If they tell you delta H is a negative number, then you should remember it's exothermic. If you don't remember that, write it down, okay? Now, I don't think that's the way they'll give it to you. That would be the thing I would think is the lesser of the two options. I can't swear to it, but that would be what I'd say no to, okay? I think they'll give it to you in an equation, which is what I have on the next board. All right? I think it'll come to you as a thermochemical equation. But I don't know, which is why I'm refreshing you on this. Okay? If delta H is positive, it's endothermic. If delta H is negative, it's exothermic. Remember our potential energy graphs?
Yeah.
Okay? If the products are lower, it's exo. If the products are higher, it's endo.
Yes.
And that's what we were talking about. If delta H is positive, endo. Delta H is negative, it's exo. Does everybody have what they want?
Sure.
Okay. Now, I think you're more likely to see it written this way.
Oh.
Okay?
It's not that different.
If you see a reaction and the heat is on, all right, there's your arrow. Okay?
Write the purple and whatever color it is.
Nah, don't write the purple. Just the green and the red or orange. All right? If it says your reactants plus, and you have heat as a reactant, yields your products, it's endothermic. Okay? If the heat is a reactant, it's endothermic. Now, if your heat is a product, it's exothermic. Now, what do I mean by the heat? I'm just going to make up an equation. The number's wrong. I'm not calculating it. I'm not looking one up that's legit. Okay? Okay? See how I put a number in the equation that says kilojoules? That's what I mean by the heat. And see how it's on the product side. That makes it what kind of reaction? That makes it exothermic. Okay? Since this is a product, that means it's exothermic. Does everybody see how that works?
Yes.
If the number had been a reactant, it would be endothermic. That's the way I think you'll see it on the exam.
Okay, wait. So, it is, so if you switch like into and the word kilojoules, it would be,
If I had that 456 on the left side of that arrow, that would make it endothermic.
okay.
Yes. But this is the way I think you'll see it on the exam. I don't think they'll just flat out say the number's positive or the number's negative. Say what?
Like sometimes on the exam, like the questions just looks way too easy.
Sometimes, and sometimes they won't be. You will see some questions on the exam that will be super, super easy. And then you will see some that will be like, what the?
Is
Yes,
there frequent field questions?
Yes, there are 45, unless they tell me something different today, the last 3 or 4 years, there have been 45 questions, all multiple choice, 40 of them count, 5 of them are field tests. You will not be able to tell which are field tests and which are regular. Okay? And I've only had 1 or 2 students in the last, I don't know, 5, 6 years who've not finished. So 2 hours
They
is,
still pass?
huh?
Still pass?
If we get 2 hours for 40 questions and you gave us an hour and a half for 70, we should be fine.
You should be fine. Put it this way. When y'all get to the 5-minute warning and you've not finished the test, bubble something. Don't leave it blank. Okay? And I have had people leave it blank. You do know if you leave it blank, they're kind of wrong, right?
Yep.
It is stupid. And every year I have people who leave things blank on multiple choice tests.
Wait,
It is stupid. So what?
Is it on paper?
No, it's on the computer. Go to the questions and mark something. I mean, I don't care. Just bubble B at that point. Okay? At least you have a chance of getting it right. If you leave it blank, it's automatically wrong. All right, so if we look at this question, all right, we're going to figure out some things about concentration this time. All right, we want to know the direction of shift. We want to know the concentration of oxygen. And we want to know the concentration of water.
If they give us like a problem, like one of these, or like the ones we have to find K, will they have it balanced?
A lot of times, based on the release questions I've seen, they do balance.
And if it's not balanced, will they tell us, or do we need to just?
Sometimes they'll say unbalanced. If you see a coefficient, assume it is balanced. If you do not see a coefficient, I would double check. Because then, like you said, in 2 hours with 40 questions, I think you'll have time to double check that. I've got sample questions to send home with you today. So you've got time to work on them between now and Thursday. You'll get a feel for what types of things they're going to give you. Most of the ones I have are 2013 and 2014 questions.
Does the exam like change very much from year to year?
I don't get to see it, so I have no idea.
The release questions aren't like old exam questions?
Every now and then I'll add a couple more to the release questions, but there's not a ton of them out there. And I don't even get to get the makeup exam, so if any of you are absent on Friday when we do makeups, I will not be the one giving it, so I don't even get to see it then. If I give a makeup exam, it will be for a different subject area.
So question, say this thing does this.
He won't be here, he won't make it up either. But go
Does
ahead.
he just fail? He's already failed, but.
Take it again.
So
They'll probably put it in physical science.
if he failed the
And you
test,
still.
but he takes the exam and he passes.
He's failed.
Does he have like a
Huh?
10?
He has a 0. He hasn't been here one day this quarter. He has no grades.
He came that day when he was on yellow.
Yeah, but he has a 0. We didn't take a grade that day. He's missed every day this quarter. He has a 0 average.
Wait, so
No, he didn't miss every day.
This quarter, he has missed
Oh.
every day
like,
this quarter.
hypothetically,
He
like,
came the
never
first
came
week
to
of
school.
I didn't say the semester. I said the quarter.
If he like if he got like a 0 first quarter, and
He got a
then
50 first quarter.
okay, then like came the second quarter, got like 100 by chance on the test, could he pass?
No.
Okay, that makes
Go to
sense.
school.
Never mind.
All right, so if we look at the equation that you have in front of you, is it endo or exothermic? It's exo. How do we know it's exo?
Because of the product.
All right, this right here is the heat. Okay? Let's fix that. The heat is a product. So that's what tells us it's exo. Is everybody okay with how Karina made the leap? Sure, does not sound overly convincing. What about the rest of y'all? Yes? Okay. Now, if that is where the number is, okay, this is the hot side. This is the cold side. It's that simple. Wherever the number is the hot side. Wherever the number is not, it's the cold side. Okay? Now, apply your rule. What did the rule say? All right, oops, too far. Okay? If I remove heat, I go to the warm side. If I add heat, I go to the cold side. All right, so my question said, oops, wrong way. All right, if I add heat, I go to the what? I go to the cold side. So, which way am I shifting?
Wait, but I'm confused. I thought you said when we're doing it like the moles, like the left side has 3, right?
Mm-hmm.
And then the right side has 2. You said it wouldn't change, so wouldn't it?
It doesn't have anything to do with moles at this point. Temperature has nothing to do with moles.
So that's not.
So we don't care about moles in this situation with temperature. You're looking at where the heat is, okay? So if we add heat, we go to the side that's cold, the side the heat's not on. So what side is the heat not on? The left. So we're going to shift to the left, okay? Has nothing to do with moles this time. Now, what's going to happen to the concentration of O2? Remember what we talked about. When we shift left, what happens on this side? It increases. What happens on this side? It decreases. So, what's going to happen to oxygen? It's going to increase. What's going to happen to water? It's going to decrease. All right. If I remove the heat, what's the rule? It goes to the warm side. Okay? That's the side with the number. Okay? The warm side is the side with the number. So what side is the side with the number? The left or the right? Shifts to the right. All right, so what happens to hydrogen? You shift right, what happens on this side? What happens to this side? So what happens to hydrogen? Decreases. All of that has to happen in your head to figure that out. I know that's a lot. Okay?
Can we just think of it as it going to the opposite side? If we add heat, it goes cold, so it balances out.
You got to think about where the number is. Okay? So,
Okay. I do have a question, y'all.
yep, I'm just writing an
Okay,
example up top.
so. Is there like
You got to learn the rules. That's where people struggle in this topic.
So
Say,
Say what you need to ask yourself again when you're trying to figure out the direction of the ship.
All right, first you have to know the rules. Then you have to figure out direction. And then you can figure out what happens to concentration.
And limits is that if we add heat, it goes to cold, and remove it goes to warm.
So, if I increase temperature, you got to know the rule. Do I go to the warm side or the cold side? Okay, so looking up there, where's the cold side? The one with the number or without the number? Without the number. Okay, so you know this right here. That's the heat. Okay, so this right here is the warm side. This is the cold side. So which direction are we shifting? Okay, we're going to shift right. Okay, that's what's got to happen when you increase the temperature. I got to shift to the right. All right, now if I shift to the right, you know, shift to the right, what's going to happen on this side? Am I going to increase or decrease? What's going to happen on this side? Okay, every time you say shift right, this happens every time you shift right. That's not unique to pressure or temperature.
Oh, is
This is always going to happen.
I mean, that's what you said, always.
And it stays the same when it shifts right. Okay? So now superimpose this on your equation. Hydrogen is on the left of the arrow or the right of the arrow? It's on the left. So what's going to happen to hydrogen? It's going to do what? It's going to decrease. Because it's a reactant.
It's guaranteed that where it shifts, it's going to increase. Like, if it shifts right, it increases on the right.
Yes.
If it shifts left, it increases on the left.
Yes. That's correct.
Whichever way it shifts.
Whichever way it shifts will increase. If it shifts right, it increases on the right. If it shifts left, it will increase on the left. That's what Caroline just said. Okay? All right, last one. It's concentration. This is the one I always start with, and students have told me I was an idiot. So I don't start with concentration anymore.
Is this a really hard one?
No, I don't think it's hard. It's one I always start
You
with.
don't think that because you went to college for this. You
I
love
still can't believe
this.
you did this. for
We
what,
know.
4 years?
We don't. We
Yeah,
don't
why?
we don't like it all.
I mean, it's not bad, but it just
We
seems really stale. Like, I was getting tired of it.
What else?
This.
I think
5
it
semesters,
does.
I can stop doing it. Now, if you add a reactant or product, doesn't matter which one, it's about adding. If you add something, it will shift to the side that uses it up. All right, you need to get rid of it if you add it. So, if you add, essentially, you have to go to the opposite side. Okay, that's the key. When you add, you have to shift to the opposite side.
Isn't that with all of them? Or am I like crazy? Or
I don't think I even know about late bus anymore.
huh?
Apparently there was a late bus. It was bus 59 actually.
What did it get?
A while ago. All right, everybody got it?
No.
One to three's changed a little bit, and today.
What did it change to? 10 to 12.
3 to 5. But it does say 60% now.
To 60.
Didn't it like thunder a week ago?
I don't
That
remember.
like some thing that your grandma said.
If it's under
Still like snow ago. That's what my grandma always says.
Yeah, everybody always says if you get thunder in the winter, 7 days on
But
that.
it's happening.
I can never forget, but I just hope it's snow.
And it,
I've always heard that.
it's thunder.
Let's just hope it doesn't happen. All right. So if you remove a reactant or a product, okay? If you remove a reactant or product, it shifts to the same side. Okay? If you don't want to write the green bold, write what I wrote in orange. Okay? It will shift to the side that makes more.
That's not all.
Okay? Anytime you remove a reactant or product, it will shift to the side that makes more. Okay? Or it shifts to the side you removed it from. Shorthand for that is it removes. If you remove one, it goes to the same side.
When you say remove, you thought remove heat.
Like, no, remove a reactant or product. Remember, we're just taking away a reactant or product. We're changing concentration. We're not changing heat, we're not changing moles, we're removing a reactant or product.
So if you add oxygen to like the left side of the equation, it'll shift right.
It'll shift right,
And then
that's
if you
correct.
remove it from the right, it'll shift right. No.
No, it'll shift to the right. It'll stay to the same side you removed it from.
Not do anything with balls.
Nope, nope, moles only affects pressure.
This is confusing.
No.
I almost chucked this topic to do something else this weekend.
And you should have.
I thought about it, but I would put money on this will be on the exam.
How much?
A hefty amount. If I had to guess.
Oh. Would you put tax returns for nothing?
Solubility graphs will be there, so we're gonna do those tomorrow. We're gonna do molarity. Solubility graphs are easy.
What about
Molarity will be there, we're gonna do it.
Remember that forever.
We're gonna do nuclear, because that's easy.
I just guessed.
All right, everybody good? All right, so let's say we have this. Okay? N2 plus O2 yields 2NO. And then I've got a variety of things we're adding.
That's a lot.
Mhm.
So like, can you remove it? Like, could you do these the other way, or do you have to?
Yeah, I could say remove O, add nitrogen, add NO. Could do any of them.
So
Those are just ones I selected.
when you like add or remove something, you do it to the side it's already on, right?
Mm-hmm. Yep.
And we're just saying like what direction it shifts.
And then I'm going to ask something about something else. All right, so if I remove or add oxygen, okay, I want to know the direction of shift, and let's say that I want to know what happens to the concentration of NO. Okay? So if I add oxygen, what's the rule? Do I go to the opposite side or do I stay on the same side? Okay, it goes to the opposite side. All right, so what's the opposite side if oxygen is here? Okay, oxygen, first of all, this is the left, that's the right. Maybe that helps us some. Okay, oxygen is here as a reactant. Okay, so what side is it going to shift to?
Right.
It's going to shift right. So when it shifts to the right, this is the part we were talking about, never changes. What happens over here? What happens over here? So what's going to happen to my NO? Correct.
And that's it.
That's it.
Okay. Well, it's
Okay.
not as bad as it could be.
Okay. So if we do remove nitrogen, again, we want to figure out the direction of shift. And let's say this time we want to figure out what happens to the concentration of oxygen. All right, so if I remove nitrogen, okay, well, let's talk about what direction it's going. Okay, what direction is it going? Okay, why do we say left? What's the rule? Same side. Okay, anytime we remove, the rule is it stays on the same side. So it's going what direction? It's going to the left. Is everybody okay with the people who said Same side and left, because all of those answers were correct.
I mean, I'm good with the left.
Okay. So Almaja said it was going to increase. Let's see if she's right.
I said
Oh, you said decrease? Oh, okay. Let's see if she's right with decrease then.
Okay, wait, but if it doesn't.
I don't know the answer. I hadn't looked at it. What?
So if it doesn't move, but it's on the left side, are we just gonna say the shift left, even though it didn't go anywhere?
Anytime you remove, it's going to the same side.
Okay,
okay,
but it didn't move though. Like, it went from where it was to where it was.
It's okay.
So,
Wait, what?
So do we
So
put
wait,
same or
shift?
The equilibrium is disturbed. So it was at equilibrium. It was at equilibrium. We took N2 out of the equation. So the equation is shifting back this direction in an attempt to make more of what just got taken out.
Okay, now it makes sense.
Okay?
It doesn't, but it makes more sense to what you were saying.
Okay. The reaction is going back and forth, making NO, NO making N2 and O2. We have removed a whole bunch of this. The equation is now not at equilibrium anymore. So the equation is trying to produce more of that N2 that just got taken out of the container. So it's working backwards to try to make more of that N2. It always wants to be equal. It's trying to make them both. It shifts left because it goes back to the side that it was on.
Same side?
Now, what happens to O2 if it shifts left? All right, this side, anytime it shifts left, what happens over here? It increases.
See what I'm saying?
It's, yeah, because left and right are opposite.
Because it shifts that way, so it increases.
Okay.
Anytime it shifts left, whatever's on the left will increase. Whatever's on the right will decrease.
So it's like literally if you were to flick the
Oh.
So is N2 on the left or on the right? Look at your arrow. Is it on the left or the right?
You said N2? Oh, that's on the. Like, what area you looking at?
I'm looking at this arrow. So if I write the equation, N2 plus O2 yields NO, where's the N2 at? It's here with the increase, so it's going to increase.
This is not
left,
fun.
but we're not finding it into it.
Oh, find an O2, sorry. That's why y'all don't understand what I'm saying. We're looking for O2. So is O2 on the left or the right of the arrow? It's on the left, so it's going to increase.
I don't like this.
I know. All right, if we remove NO, what direction is it going to shift?
Right. Wait, what?
If we remove NO, what direction is it going to shift? I hear right. Do y'all like that answer or no?
I mean, it's the only one that.
It won't shift.
It won't shift. It's always going to shift.
But not there.
If they're equal, it doesn't.
This is right.
Remember, we disturbed the equilibrium, so it's got to shift left to right. So don't tell me it's not going to shift.
It has to shift somewhere. It will shift to the
So the way
right.
that you said it, if you take it out, it's gonna shift to the right to try and make up for.
Yeah, it's got to shift to the same side. So those of you who are yelling to the right,
You know what? You make me not confident.
Okay, so we.
My head
don't
hurts.
like
It's way too early.
huh?
It will increase.
Okay, so which thing do we want to find? Let's say we find N2's concentration this time.
Oh,
Okay, so if it shifts right, what happens to N2?
It decreases.
It what?
Decreases.
Yes.
You said that.
All right. Last week, we did a worksheet where we found the 5 Ks. On the back side, there was a worksheet, and I told you not to lose it because we were going to use it again. Do you think you can locate that worksheet for me?
No.
You weren't here. You need it.
This one?
Yes.
What one?
I lost it.
We did the front.
I remember that.
We had sent it.
We need that.
Everyone got it all wrong.
Yes, you did. And we went over the front.
Kind of.
This practice. Are we taking any more notes? Yeah.
No, please don't.
I don't know.
Let me see the.
No,
other
The front looked like this.
Oh.
Green.
Huh?
Yeah, we're doing LeChatlier.
That's
give you a
what
little
this
copy of that.
That's what this is?
Yeah, it's LeChatlier.
I didn't know that.
You
Yeah.
spelled his name wrong on the board.
I gotta get it all around.
Mr.
Oh,
E.
Missy. Oh, well. All right.
I need to write that down, because I didn't know that's what.
I'm so
Oh, I did write that down. What if I start with
All right. So if we look at the paper, we're going to make an attempt to answer these questions. God help us all.
God help all God. If I could take like a 5-minute nap.
You can have a 5-minute nap between first and second period.
Between first and second, okay. 5 minutes here, 5 minutes here.
Where are you going?
I had to get up and walk around. I'm really like to look.
All right. Pick a line you want to do together. Number one's already done for us.
Let's do one.
Let's start from the bottom and go up.
Nope. Pick one line, not 2 through 10.
Okay, so.
All right. Line 7. Now here. All right. So line 7 says increase temperature. So what's the rule if we increase temperature? It goes to what? The colder side. So look at your equation. All right. This right here is the heat, right? So that means this is the hot side. This is the cold side. So if I increase temperature, it goes towards the cold side, which means it goes which direction? Okay. So I'm going to put left here. Okay.
It increases on the left.
Okay. So that means if I go left, it will increase here and decrease there, which is what Karina just said. Now, you don't have to write this part. I'm just writing down what she said. Okay? Because that's going to help us fill in these 3 parts right here.
Okay.
Okay? So, what's going to happen to N2 then? It's going to increase. It's going to happen to H2. It's going to increase. All right, now we're a product. So, it's going to do what?
Decrease.
It's going to decrease. Now, who remembers what would change K the other day? I told you only one thing affected K. Yep. All you got to write is it changes.
Okay.
Okay? Now, you don't have to know how it changes, just that it does. Okay? If you were in an AP class, you'd have to know how. Now, the rest of those lines, I want you to fill in.
No, you just said we was gonna do them together.
No, I didn't. I said we were doing one together.
No, you said find the paper. We're gonna. So sleepy. You said we're going to attempt to answer these questions. God help us all. Miss Wall help us all.
I'm going to help you all go over them in a minute.
Okay, so,
K is the only thing that affects temperature. So the rest of them, you'll find has no effect. Okay, remains the same. But temperature affects K. See if you can answer those, not just sit there and stare off into space.
you're just adding an element.
If you add, it goes to the opposite side. That's concentration. That's what we just did.
Wait,
If you add, it shifts to the opposite side. If you remove, it stays on the same side. Probably not.
Oh,
Just kidding. Fortunately for you and Elijah, you sing better than you do chemistry.
Oh, yeah.
Oh, I thought you.
Wait.
And then she said, just kidding.
Try to keep up no problem. Adding
That
next
started
thing,
singing
just
when
the
you
left.
the whole background check.
Oh,
It sounded like somebody was behind the curtain.
They were just like on bust out or something. That's
I'm about to go do chemistry.
oh, fantastic.
But she was a whole lot better.
Yeah, they look fine. I don't see anything looks wrong. You look fine. Keep going.
Okay.
What's wrong? Huh? If you add hydrogen, it goes to one side. Same or opposite?
Oh, Lord.
Using temperature.
Wait. I thought it was David. What is it?
Yep, so
No.
find H2, what side is it on? So we'll shift to the left. Shift right. If it's not temperature, it stays the same.
Wait, so if it shifts to the right,
Yep, so in this here, so anytime it shifts right, increases. So put it right here.
yeah, it increases
So
the
where's
left
N2?
since it should be.
So we'll do what?
Yes.
Yes.
If you add one of the elements, but it goes in the opposite direction. does that
Oh,
mean
pressure's
it's
more.
decreases?
So what now?
Like, so you add hydrogen, but it goes to the right because it goes to the opposite side, so it's still decreasing even though you're adding them.
Yeah.
This is
Adding-
always that one, this is right.
Yeah. Is it got a line here? Who's the line in that line?
Wait, no, this one, and then this one.
You're adding hydrogen, so you said it went to the right. So N2 is going to decrease, yeah.
And we don't answer,
You don't answer the one that's blanketing. So I
That's what
told you you added hydrogen, so you're
but
not
it,
gonna answer that.
so we'd never be asked like if that increases,
Yeah, because you added it.
so it increases.
Yeah, because they already told you you added that. So they just want to know what happens in extreme. Yeah. Yeah. Who else has a question?
I don't have, I don't know what to ask.
So if you decrease temperature, yep, because that's the hot side.
Wait, so you decrease pressure?
Goes to the side.
No, it goes to the side that has the heat on it, and the heat is that number, it's on the right. Yeah,
Okay.
okay, so if it, hold hang on a second. So if it increases, or if it goes to the right, this side will increase, this side will decrease. So this side is the right, and that side is the left. So what happens to N2? Yep,
But if you move in that way,
these two would do what?
Oh, no, it would.
Only this would increase, because that's on the right of the arrow. But these two things on the left of the arrow would do what? Whatever's on the, see how I drew the arrow? The reactants? The reactants would do what? And the products would do what? So these two things that are reactants would do what? And the product would do what? That's a reactant. Reactants are doing what? Decrease. Okay, hang on. So this is a reactant, and reactants are doing what? Change that to decreasing. All right, what's your question?
Oh, no.
Oh, no. The only thing that changes is that.
Said something.
What's the rule? You increase pressure, you go to one more
Oh, no.
which side is less wrong?
That would be so funny.
Yep.
Like in the
And then you go back and these,
I'm a good
and then you go back to those. Because you applied the rule right. Correct. You applied this correct because you made it wrong. Right.
Like what?
All right, who else has a question?
Do you want to check?
We're ready for them. But what?
You can buy some.
Wait, with pressure, if it increases, it goes to the side that's less. Right?
If you increase pressure, you go to the side that has less moles.
She said, "I'm gonna get a whole."
Not a whole stick hole.
It's okay. What was that? Yeah, it's worth it. They should. Is this the back?
Wait, what is this? Oh, you have them covered up.
I do.
Right. What?
No, no, are you crazy? I don't almost have to cut my head.
Oh, you're really tired of that?
I am done.
I want to buy some of those.
That's nice.
It's
Honestly, really smart.
There's
I've already
like a-
lost them twice.
There's a 4-pack for $60. That's not so. Add them to the next.
All right, let's look at what some of you came up with. Some of you are done, some of you aren't. So in the top one, anytime you add, what do you do when you add? The same side or the opposite side? All right, when you add, you go to the opposite side. So the opposite side of H2, look at where H2 is at. H2 is here. It's a reactant. So the opposite side of the reactants is the products. So that's why it shifts to the right. So anytime it shifts to the right, this side will increase, this side will decrease. So N2 is going to decrease, and that one's going to increase. All right? Same thing when we add NH3. NH3 is going to do what? Go to the opposite side. So NH3 is where?
On the right.
It's on the right. So it's got to shift to the what? It's got to shift left. So it's going to shift left. These two things are going to increase, and that's going to decrease. So these are going to increase. When we remove, anytime you remove, it goes to the same side that it's on. So N2 is on the left, so it shifts left. Anytime it shifts left, increase, decrease. So H2 is going to increase, and H3 is going to decrease. K stays the same because it's not temperature. All right, when we remove H2, it's going to stay on the same side. So left, increase, decrease, same. When we remove NH3, same side. NH3 is a product. So it's going to go to the right. It's going to decrease, decrease, stay the same. Number 7 we did together. Number 8, if we decrease temperature, I got to make it smaller if you want to see the equation. Okay. You're going to go to the right. You go to the right. These things are going to decrease, decrease, increase. Temperature, all I told you had to write there is it's going to change. These two should just say change. You don't have to know if they increase or decrease. You don't have to know the rules. Number 9, if you increase pressure, we go to the side of less moles. Which side has less moles? The right. So decrease, decrease, and increase. And then when you decrease pressure, you go to the side of more moles. So you go left, increase, increase, decrease. Questions?
No.
All right. I'm going to give you more practice of this tonight.
How much?
A little.
Like 2 questions?
Front side of the worksheet.
That's not a real picture though.
All right, let's do something easy.
Sleeping.
No. Nope. All right, let's do molarity. Nope. I'm chucking flickers and solubility. We're going to do something easy. Y'all are a little stressed. Molarity should be easy for us.
It's all your fault.
I can't fix it. It snowed we lost 6 days, plus the hurricane. Nope.
I need to.
Look, I'm never dead.
It is. All right, there's 2 math formulas that we can do that are pretty easy. All right, molarity is the easiest of the 2. And the nice thing about molarity is that you already have all of the skills to solve with the molarity and the dilution formula that we'll talk about tomorrow.
Are you sure I do?
Mm-hmm.
Or are you just
Positive.
I think you're reaching.
I'm not.
That's a reach.
I am not. I promise. Molarity is moles of solute over liters.
Nope. Wait, should we have done solubility?
Yep,
So why are we?
because this is easier. And you don't need something easy that's low stress on your brain.
Of solution?
Over liters of solution. Now, the short way to write the formula is big M equals moles over liters. Now, this formula is on your reference table, so it's not one you have to memorize. Okay? You will not have to do that. You can look it up. Now, the nice part about this formula is everybody in here knows how to find moles. Everybody in here has been successful on every quiz and test in finding it. And I'm pretty certain everybody can change milliliters to liters. Now, if I was guessing, you might get your milliliters in liters and won't even have to change that on the exam. Most likely, you will either have to solve for grams or you'll have to solve for molarity on the exam. Which one? No idea. Molarity is the big M. If they ask you to find grams, they're going to give you molarity and volume, and you're going to have to change and find the grams. Either way, it's not hard to do. Okay? So, you already have all the skills you need to do this. Okay? You just have to think through the questions. Does everybody have the formula?
Sure.
Okay. So, if they give you a question where they say, what is the molarity of 125 grams of NaOH dissolved in 500 milliliters of solution. You already have all of the skills you need to solve that question.
And what skills?
Well,
Teacher, change grams.
yep.
I'm sorry, Ms. Wall.
And if you thought about it, you'd have given me the same answer.
Nope.
Yes, you would have.
I didn't think about it. So
That's why I said if you had thought about it. Yes, you do think. You might not like to think, but you know how to think.
I mean,
I think I need
because I overthink everything.
This one is not one you can overthink.
You would be surprised.
Overthink everything. That's a lot. Wait,
All right, so the formula wants molarity equal moles over liters, right? So we're solving for big M. I need moles and I need liters. So what am I going to do with that 125 grams? Change it to moles. So 125 grams. What goes on the bottom? What goes on top? What goes beside moles? How do I get my grams? All right, so how many NAs do I have? How many O's? How many H's? So that makes it nice and easy. 23, 16, 1. Add all that up, you get 40. So I'm going to put 40 there. So, let me get my calculator. I can't do that in my head. Is what?
3.1. Really? That's high.
Close.
What is a unit?
Capital M or moles per liter.
3.1.
All right, now, what am I going to do with that 500 milliliters? Yeah.
We're not done?
No, that's just moles.
Oh, wait, it involves what?
Now, I told you back in the gas laws I'd learned that 500 divided by 1,000 will give you liters. But you can draw a T-chart if you don't remember that. Divided by 0.5 liters gives you, Randy, you got that divided for me? It's what? 6.25?
Yeah.
Now, you can write your units as either big M, which you can do, or 6.25 moles over liters. That's the way I tend to write them. But you remember last week when we were calculating equilibrium and you had all those units that were moles over liters?
Yeah.
A lot of times questions prefer to use moles over liters. Okay, which is why I wrote them that way last week, so you were used to seeing them that way. Okay? Now, that's one way that you might see this question. Okay? The other way is it might ask you to find grams.
We don't have time. No.
That's
You guys
fine.
have the homework.
Mm-hmm. Okay.
Don't encourage me.
I'm ready to go. I don't want to do more work.
I got no problem with that.
I do.
Honestly, I just don't
I'm
think
already upset with my grade.
Here, Sailor, come here. Now, on the sheet that Sailor's going to hand you. On the sheet that Sailor's going to hand you, you're doing 1 through 5. For those of you who are that slow tonight and you're looking at these and you go, oh, these are multiple choice. They are not multiple choice questions. Okay? Do not circle A, B, C, or D. Particularly the ones that are only A, B questions. It's not an A or B choice. They're individual questions. Answer each individual question.
That's a lot of individual questions.
You know what?
You're only doing 1 through 5.
Okay. I'm pretty sure Luis isn't as stressed as we are.
Luis doesn't care.
Exactly.
So let's failed and moved on.
What's that right there?
The papers I'm handing you is your review or part of your review for the exam.
He never did.
I need you to do this by Thursday. Oh, wait. It's only 40 questions.
You said we're only doing through 5.
You're only doing through 5 on that worksheet. The paper that I'm handing you is the review. I need you to do it by Thursday. I need you to do it by Thursday.
What about Friday?
By Friday, I hope to have gone over it.